In this video, we're going to be looking at the concept of 2D arrays in computer programming. So first of all, let's talk about what are 2D arrays. So if you think of a one-dimensional array, 2D array is just another dimension on a 1D array. So it's structured like a table or a grid. Now you have rows and columns, and I've marked these in red and green, and this will be consistent all the way through the video. It's similar to a 1D array in the following ways. Each element in the array has an index, okay, except this time it has 2 digits, and each element in the array has the same data type. So like a 1D array, if you set it up as a string, it can only hold a string. And if you're thinking about pseudocode, you would set up the above array, the one that's shown here on the sort of top left, as declare mygrid, then a colon, then the word array, and then in brackets the row, the number of rows, and then in brackets the number of columns. An alternative way of doing this is to write a single set of brackets with a comma in between, but you can also write it like this. And then finally you finish by saying of string, or of whichever data type you want the elements in the array to hold. So now our two-dimensional array is set up, let's look at noughts and crosses as an example. So we have the same grid with 3 rows and 3 columns, set up in the same way. But if we set the value of mygrid, row 1, column 1 to be x, we get an x in the middle. If we set mygrid, row 2, column 0 to be O, it goes bottom left. If we set mygrid 0, row 1, row column 1 to x, we get the top one. If we set mygrid row 2 column 1 to O, we get sort of bottom middle, and then we make a mistake and mygrid 0 0 top left makes x, and then the last one is that we can make mygrid row 2 column 2 put a 0 or an O in the bottom right hand corner, and if we had the game logic that would finish the game, but as it is we are just setting values in our two-dimensional array. So let's look at some other things we can do with two-dimensional arrays. If we want to, for example, display all the elements in a 2D array, we first set up our two-dimensional array in the normal way, and then we can use a loop, but we have nested for loops. So we loop for all the rows, then we loop for all the columns, and then we just display the value of mygrid at that row and that column. And then we end the for loop for column so that it shows all the columns, and then we end the for loop for the rows, and that ends all the rows. What will happen is this will output each element in the array on a different line. So you might have to think of some string concatenation or string formatting if you want to display it like a noughts and crosses grid, for example. And here's a useful function. If we want to find an element in a two-dimensional array, then you set your target, and then as before you loop for all the rows and you loop for all the columns, and then you test each element in order. So for row 0 to 2, for column 0 to 2, and then you say if the current row and the current position matches the target, then you can say found at row column. And then we end the if, then we end the for the column, and then we end the for the row. So let's run through this example. So if we start off with setting row to 0 and column to 0, we test the top left here, and we say that if mygrid 0 0 is equal to the target, which is O, then we output found at row column. It's not, so we move on, and column becomes 1, and we test column 1. We say is that equal to 0, or O, sorry, it's not, and so we go for column 2, and we test that, it's empty, so it's not found either. Then we finish our next column, and we go round, and row becomes 1, and we start again. And so for this one, row is 1, column 0. Is it O? No. The next one's row 1, column 1. Is it O? No, it's not. On to column 2. Is it O? No, it's not. And we go down, next column, we go back up to row becomes 2, and we start the column loop again. And for row 2, column O, is it equal to O? Yes, it is. So we output found at 2, 0. We then move on to the next one, and column becomes 1, and we test it, and is it equal to O? Yes it is, so we output found at 2, 1, and then we do column 2 on row 2, and is it O? Yes it is, so we output a third found at row and column, but in this case it's found at 2, 2. Then we end the column loop, and finally we end the row loop, and that's the end of the program. And we would have 3 outputs that would say found at 2, 0 or 2, 0, found at 2, 1, and found at 2, 2.